Hello, this is Miss Parks, and in today's video you are going to learn how to divide polynomials. So before we do this, which looks very intimidating, we are going to do a fourth grade long division problem so that you can see how this part is related to polynomials, and then hopefully it will make it less intimidating. So when you divided polynomials, when you first learn, or not polynomials, excuse me, when you did long division, when you first learned this, you did 12 into 53. Okay, so 12 into 53 is 4. And then after you divided, you multiplied down, and we have 48. After you multiplied down, you subtracted. And if you subtract that, you get a 5. And then after you subtract, you bring down this 5, and then you start the process all over again. So then you do 4 into 55, which is another 4, and then you multiply down again, and then you get 48, and then you subtract, and then you get 7, and that's your remainder. So there's two ways to write this answer. You can say 44 and 7/12, okay, where you put this over this, or you can write it as 44 remainder 7. And I'm going to do this when we do our polynomials just because it's a little bit shorter to write, but just so you know that you can write your remainder over this part. So I am going to show you how to do that in long division of polynomials. So we set this up. We're going to divide by this. So we have x squared plus 3x plus 2. And we're going to divide that into 2x to the 4th plus 3x to the 3rd. Now, we don't have an x squared, but we need to leave a space for it. It's like having 107. You wouldn't write 1 and 7. You wouldn't just write the hundreds and then ones. You would still put a 0 for the tenths place. Otherwise, it looks weird, so you wouldn't want to put 17. So we need to leave a space for the x squared part. So it's this part, we have 0x squared, and you'll see in a second why that makes sense. And then we have plus 5x, and then minus 1. On the outside, you can use a placeholder if you want. On the outside, it's not necessary, but it would not hurt if you wanted to do that. So you always start at the highest exponent, and you work your way down, and you need to make sure you account for every power from the highest down to the whole number. So even if the constant number was missing, you would still put a 0 there as well. Okay, so let me go back to this one up here so we can see what we did first. So up here, what we did is we took 12, and we saw how much it goes into 53. So the x squared is really like the 12, the one on the outside. So you're going x squared into 2x to the 4th. So if you were dividing that, it's basically x squared times what gives you this number. Okay, so x squared times 2x squared is going to give you x to the 4th. And then we need to multiply this down. Okay, so we're going to multiply down by all of these. So 2x squared times x squared, 2x squared times 3x, and 2x squared times 2. And this is why we need this term, because if this was gone, then this 4x squared would be under the 5x, and then we would have a problem. There would be nowhere to put it. Okay, so we need that 0x squared. So what we did is we just did 12 went into 53 4 times. 4 times 12 is 48. And then after we multiplied down over here, we subtracted. So we need to subtract all of this. So instead of putting parentheses with a minus sign in front, we're just going to pretend the minus sign was in front and there was parentheses there. We're going to distribute that. So I recommend you use a different color, and then we're going to change the signs of all this. So this becomes minus, this becomes minus, and this becomes minus. If it was already minus, it would become plus. Okay, so we're going to add that down. I just deleted that, so let me put that in again. All right, so we're subtracting, so those cancel. 3 minus 6, that's negative. 0 minus 4. So then after we subtracted, we brought down this 5 over here, so we're going to bring this down. If you want to bring both of them down, that's totally fine. It doesn't really matter if you want to bring one or both. Then we started this and we did this all over again. So next we went 12 into 55. So now we're going to do x squared into 3x to the third. So you're trying to figure out x squared times what will give you this. It's the same thing as dividing. So that's going to be a minus 3x. And then we're going to multiply that down. So 3x, or negative 3x times x squared, negative 3x times positive 3x, and negative 3x times 2. After we multiply down, we need to subtract. So when we subtract, we need to change the sign of everything. So this is going to become a plus, that will become a plus, and that. And I again suggest that you use a different color so you can see that you've changed the signs. When we do that, these cancel. You're going to get 5x squared plus 11x. And then we're going to bring this guy down, which is a minus 1. And then this will be the last one because we ran out of numbers. There's no more numbers here. So that's how you know that you're not going to do any more division. So then we have x squared into this, into 5x squared. So again, if you divided that, you would get a plus 5, or if you're trying to figure out what you multiplied by. So x squared times positive 5. And then you have to multiply down. So 5x squared plus 15x and plus 10. And then if we have to subtract, remember, so we're going to change the sign of everything. When we do that, those cancel, and I get minus 4x and minus 11. That is my remainder. So I'm going to go ahead and add that up here, remainder minus 4x minus 11. And this whole thing is your answer. Now, if you didn't want to write it in remainder form, then, and if you check in the back of the book, here's how they'll write that answer. 2x squared minus 3x plus 5. And then this is the remainder. So they would put like this, but they would write plus negative 4x minus 11 over x squared plus 3x plus 2. Or they might write minus 4x plus 11 over x squared plus 3x plus 2, because that minus sign would distribute. I'm going to have you go ahead and use plus on this. And you can do it that way. I'm going to go ahead and write the answers like this, just because it'll be a little bit easier, especially right now when we're learning, and it just doesn't take as much room on your paper as well. You just take the remainder that's down here, and you multiply or add it into the top. Just leave some space here, and then remainder, leave some space, and then write that in. Okay, so for this problem, please pause the video and then try it on your own. Don't forget that you do need placeholders. It starts as the next to the fourth, so you need to make sure, actually let me set it up for you, just make sure. So we have x squared minus 3x minus 2, and that's going to be divided into 4x to the fourth. Then we have 0 x to the thirds. We have 0 x squareds. We do have 5 x's and minus 4. So do the problem, while you pause the video and then come check. A lot of times, if you don't want to check everything, if your remainder is the same as my remainder, then that means like 99% of the time that your answer is correct. Okay, so here we go. So we're using x squared, and first we're going into 4x to the fourth. Again, hopefully you finished this already before you come check your answers here. So x squared into 4x to the fourth means that I would have to multiply x squared times 4x squared to get that. Then I'm going to multiply down by everything. So again, you divide, then we multiply. 4 times negative 3, that is minus 12x to the third, and then 4 times negative 2. Now we're going to subtract, which means I have to change the sign of this. Use a different color. So I'm going to use this, and that. So change the sign of all of them. Then that gives me 12x to the third plus 8x squared, and then I will bring this down. And next I will go into 12x to the third. So if I go into 12x to the third, I'm going to get, let me erase these. So x squared times 12x, that would be positive. And then I'll multiply 12x times x squared. 12x times minus 3x. And 12x times minus 2. Then I'm going to subtract. So if I subtract, that becomes minus, that becomes plus, and that becomes plus. Basically, you change the signs of everything. When I do that, I'm going to get 44. That's an x squared there, sorry. X squared plus 29x minus 4. And then I will do x squared into minus 44x squared. So for that last part, it's x squared times positive 44. And then we will multiply down. All right, so when I multiply these down, I'm going to get 44 times x squared. Then 44 times minus 3x. That's minus 132x. And 44 times minus 2. Then I have to subtract. So I have to change the sign of everything. That becomes minus, that becomes plus, and that becomes plus. So this gives me 161x plus 84, which is your remainder. Okay, 161x plus 84. And this whole thing, oh, I don't like that, highlighter in that case, is that's your final answer there. So if you didn't get that, hopefully you can figure out where the changes were or what was different in yours than mine, so you can see like where the mistake was. Please try the next two on your own and then check the answers when you're finished. I will be doing those as well. All right, so x minus 1, x to the third, minus 1x squared, minus 2x plus 8. We did not need any placeholders. Everything was there. So this will be an x squared, and then x to the third minus x squared. We multiply that down. Then I have to subtract, so it becomes a minus, that becomes a plus. These both cancel out completely, and since they both cancel out completely, I will bring down this minus 2x and this plus 8, both of them. And then x minus 1 into 2x, or x into negative 2x, that becomes a minus 2. And then if I multiply that down, get minus 2x plus 2. And then if I change the sign, which means I'm going to subtract. So that will become plus and that'll become minus. These cancel and I get 6. So my final answer, I'm going to write it from the top, is x squared minus 2, remainder 6. So that was something new that happened wherein these two both canceled out, which is fine because you still have other terms. Okay. Next. So for the next one, we will have x squared minus x plus 1 into x to the 4th plus 2x to the 3rd. We need a placeholder for the x squared because there aren't any. You can leave a blank space or you can write that in. Minus x and plus 5. So we're going to be dealing with x squared. Okay, so first we go into that. That makes that x to the 4th. Or excuse me, that makes that x squared. If we multiply x squared down, get x to the 4th minus x to the 3rd and plus x squared. Then we have to subtract, which makes that a minus, makes that a plus, and makes that a minus. You change the sign of everything. And then that gives me 3x to the 3rd minus x squared minus x. Now we're going into 3x to the 3rd. So x squared times positive 3x. And then we will multiply that down. So 3x times x squared. These should always match up. If they don't, something's wrong. 3 times negative x. That's negative 3x squared. And positive 3x times 1 is positive 3x. And then we need to subtract, so that changes the sign of everything. When we bring these down, this becomes 2x squared minus 4x plus 5. And you need to make sure that you try to keep that neat. It'll definitely be helpful if that will be neat. All right, so next we have to go x squared and 2x squared, so that will be a plus 2. Multiply that down. 2x squared minus 2x plus 2. And then we need to subtract. So that will be minus, that will become plus, that will become minus. And so in this case, we will get a minus 2x and a plus 3, which will be our remainder. And get that out of the way. And then this should be your answer. All right, so that's good. For this next section, we're going to introduce something called synthetic division. And synthetic means something that kind of achieves the same results, but isn't quite the same thing, like kind of synthetic leather. It looks like leather, feels like leather, but it really isn't leather. So synthetic division will give us the same results as doing long division, but it is a much shorter process and it's a little bit easier to do. The only problem is when we're doing synthetic division, you can only do that if you have x to the first power or 1x to the first power. For us, what I'm going to do, not x squared or not x to the 3rd or even 2x, I would rather just use long division. So the first thing is that we're only going to be using coefficients. So we're going to take the coefficients of these numbers, and I'm going to get rid of this. I don't really want that there. So I'll be using the coefficient of x to the 3rd, so negative 1x to the 3rd, positive 4x squared, 0 x's, and 9 is the whole number. So this is x to the 3rd, x squared, x, and then the whole number with a constant. Then we're going to draw a little box on the outside, and in that box, we would put whatever x value would make this equal to 0. So the x value that makes this equal to 0, if I had x minus 3, it would be x is equal to 3. So we're going to be using x is equal to 3 because that says x minus 3. We're going to be using x equals 3. So that number goes here. you will leave a space and you will draw a line, and then you'll put a box underneath the last number. Okay, so there's only two things that you're going to do here. You're going to add, multiply, add, multiply, add, multiply, add. Okay, so we're going to add 1 plus nothing, or negative 1 plus nothing, which is negative 1. Then we're going to multiply, and every time we multiply, we're going to be multiplying by whatever number is in the box. That's the multiplier. So I'm going to multiply this by 3. So negative 1 times 3 is negative 3. Then I'm going to add. So that's 1. And then I'm going to multiply by 3. So 3 times 1 is 3. And I'm going to add. So 0 plus 3 is 3. And then I'm going to multiply 3 times 3, which is 9. And then this is 18. Now, 18 is the remainder. This is the whole number. This is the x value. So this is positive. This is 1x. And then the variables just get higher and higher. So this is negative 1x squared. So my final answer here is this. Now, it seems a little bit weird at first, I'm sure. But once you get good at this, it's actually a fairly fast thing to do. In the future, you'll probably just do it a little bit faster. So you just add, multiply, add, multiply, add, multiply, and then you'll get 18. Okay, so you're always multiplying on the diagonal by that number. Now let me show you long division. You guys don't need to do this, but I'll show you that in long division. Actually, I'm going to write it right here. X minus 3 into this. So negative x to the third plus 4x squared plus 0x plus 9. So this would be negative x squared multiplied down. Negative x to the third plus 3x squared. And that's it. And then we would subtract. So I would get plus and I would get minus. So then I would get, let me add some room here. All right, so then I would get x squared plus 0x. Then I would put a plus 1x, multiply down, x squared minus 3x. Then I would subtract. And I would get 3x plus 9. And then I would divide x into 3x. That would be a plus 3. Multiply down. 3x minus 9. Then I would subtract. And then I would get 18. So you see that the answer is this, remainder 18. And if you look at these numbers, wrong ones. Let me undo that. The initial numbers we're dividing into, those are these numbers. Okay, and you can kind of see how it all relates. That 4 minus 3, that's here. That 0 plus 3, that's here. That 9 and 9, that's here. So it's kind of all the same thing. It's just a much shorter way of doing it in this case. All right, let me delete that. All right, so let me go ahead and do this one because you're learning. So this is what we're dividing by. So remember, x minus 2 equals 0. So x equals 2. That's the number that's going to go in the box. Then we do the coefficients. So negative 1, 3, 0, 1, and 0. So this is your negative 1, 3, positive 3, 1, and then 0 for the whole number. So we bring this down, we multiply. So again, the multiplier will be 2. Okay, so then we multiply by 2, so that makes that negative 2. We add, we multiply by 2, we add, and then we multiply by 2, and we add. And it's always going to be one less than whatever your first. So if this is x to the third, this will be x squared. Or you can work from a 6 and then just know that it goes from remainder to whole number, then x squared, x to the third, x to the fourth, and so on and so forth. Okay, go ahead and try both of those on example 3 and see how it goes. Actually, go ahead and try all 4 of these just because they'll be pretty fast once you get the hang of them. Or try as many of them as you want and then kind of check as you go, whatever you think is best for you. All right, so in this box, I'm going to be using a -1 because of that. It's going to be the opposite of that. Inside here, it's going to be 3, then -2, then +2, then -5. You don't need any placeholders here. All right, so this will be 3. We're multiplying everything by -1. All right. So your final answer, 3x squared minus 5x plus 7, remainder -12. The next one, because of that, we're going to be using x equal to +1. And then we use these coefficients, x to the third, x squared, x, and then the number. Bring that down, everything gets multiplied by 1. So that becomes 3, -4 when you add those, multiply by 1, add, multiply by 1, and add. So this is 3x squared minus 4x plus 2, remainder 10. And again, if that's an x to the third, your answer will be an x squared because we're dividing by that. For the next one, since that's an x minus 2, we're going to be using x equals 2 in the box. So that's 1, -3, -7, and +6. And that's going to give me 1. Everything gets multiplied by 2 in this case. So 2, ooh, that's not a good. 2, -1, -2, -9, -18, and -12. All right, so if I write that, that's going to be x squared. It's not always going to be x squared. It's always going to be 1 power less than the highest power. So I just so happen to give you a bunch of x to the third ones because those are the examples in the book. But if this was x to the fourth, then this would be x to the third. It's always 1 less than the highest power that you're dividing into. All right, minus x, minus 9. And you notice I don't put minus 1x. I don't want you to use 1 for a coefficient. Okay, so -12. It means the same thing, it's just not simplified. So you're not going to be using 1 for like 1x. You're not going to be using anything divided by 1. You're not going to be using x to the first power. So the number 1 is only used almost only when it's like the only thing at the top of a fraction. Is almost the only time you're going to use the number 1 for any type of thing, or if it's its own number, but never for a coefficient, please. Okay. All right. Excuse me. For the last one, we're going to be using x equals -3 here. So 2x to the third, 0x squareds, -1x, and then -7. So you do need a placeholder for this one. We're going to bring that down. Everything gets multiplied by -3. So -6, +18, and -3 times 17. Is -51, I believe. So that's -58. So 2x squared minus 6x plus 17, remainder -58. Okay, so we are going to be evaluating polynomials by using synthetic substitution. So again, synthetic means like a fake way of doing something. We're not really going to substitute -4 in. So synthetic substitution is going to start the same way as we did the previous problems. But if you notice here, it says x is equal to -4. There's already an equal sign there. We're not solving for x. They tell us what x is equal to. So we'll go ahead and use -4. We do the same thing as we did in synthetic. So it's going to be 5, -1, 13, and 29. We're going to go through the entire synthetic division process, but it's going to be called synthetic substitution because we're not looking for a division answer. We're not dividing this by this. We're trying to figure out what would the answer to this be if I plugged in a -4. The reason this is nice is because you don't really have to worry usually about as many of the bigger numbers or raising anything to a power. It's just addition, multiplication, addition, multiplication, addition, multiplication, addition, and that's it. All right, so we bring this down. We're going to multiply by -4. We're going to add, multiply by -4, which gives us 84. We will add these together. We will multiply that by -4. And then we will add, okay? And then we get -359. If that number looks familiar, it's because that's the answer we got when we did direct substitution. So when f of x is this function, then f of -4, which is this number, when we plug that in, is equal to whatever that remainder is. And so that is synthetic substitution. So instead of taking -4 and plugging it in for all of these x's, we could just do synthetic substitution, take the remainder, and it gives us the same result. Okay, so let me do this one. Or it's just asking you to plug in the -4 in for f of x. I'm going to go ahead and do that. We already did that work, but we'll do it again. So 5 times -4 to the third minus -4 squared plus 13 times -4 plus 29. It'll be good for you to have this in your notes so you can refer to that. 5 times -64 minus +16 minus 52 plus 29. So this is -320 minus 16 minus 52 plus 29, which is -359. So that is f of -4. And hopefully you can see that these are related, that they're exactly the same. Actually, you get the same answers using both methods. All right, so go ahead and do the last 3 problems and then check your answers when you're finished. All right, so after pausing and doing these 3, I will show you what the answers are. All right, for -2, -5, and 11, again, take a look to see if you need placeholders. Okay, so 4, -8, -10, +20, 15, -30, which makes that -19. So f of -2 is equal to -19. Okay, and then for the next one, 5. So we have 4, -10, and -21. So 4 times 5, add these together, multiply by 5. So 29. So f of 5 is equal to 29. And then for the last one, we're going to plug in a 2. We're not really plugging in 2, we're doing synthetic. So 5, 2, there's no x squared. Then x, and then the whole number. And we get 5, 10, 12 times 2, 24 times 2, add these up, times 2 is 56, so that's 50. So f of 2 is equal to 50. So you just have to be careful between the different types of questions. So when it says to evaluate, you're going to get a single numbered answer. If it asks you to divide, division, then you're going to get a polynomial as your final answer with a remainder. Sometimes the remainder is 0, by the way. If the remainder is 0, you don't write it in. It just means it goes evenly. So when you're doing division, your answer will be a polynomial. Okay? If you are evaluating, your answer will be a numeric value. Okay? So just make sure you know the difference, because you do the same work. The answer is completely separate, though. They're not the same answer. Okay?